Bass, and it's great to be at this conference. And if you adjust for the fact that Don was on the thesis committee of Carl, he's a grandchild as well. I'm going to talk about field experimental evidence on the impact of information and pricing on residential electricity consumption. So if you look at, the retail and wholesale prices during peak load, this data is from ERCOT. Again, I'm really sorry to hear about the winter storm in Texas. I hope everybody at UTD are safe and sound and healthy. So the yellow bars are the hourly day ahead prices, and the green is the daily on peak price, and the flat line is the weighted average price. And you'll see a lot of fluctuations in the wholesale prices, and on the retail level there isn't much. So to address the peak loads, utilities build peaking plants that are inefficient and dirty. And so the question is, what is the best way to have consumers reduce their electricity consumption during peak periods? And I'm also going to talk about how to make them increase their consumption during off-peak when there is a lot more power in the grid. So the three research questions that I'm going to talk about. And by the way, Jesse and Ken, if you're in the audience, just feel free to jump in. And anyone else, if you have any questions, just unmute yourself and chime in. I'm going to talk about two field experiments in Austin, Texas, designed to look at approaches to conserve residential electricity consumption, and see whether active or passive information should be provided to consumers to reduce demand, particularly in peak periods. What are the elasticities during peak and off peak, and how does this elasticity come about in terms of appliances, which appliances dominate the consumer response, and how much of this effect is from pricing versus passive information. And finally, I'm going to show some welfare gains and reduction in carbon dioxide emissions. I'm going to go through the introduction, research design, give you the data, show you the data and our approach and the results and conclusion. So I'm going to talk about passive and active information. There is a lot of evidence that says, there's access to information can matter, right? And Brian, who's a discussant here, has done some tremendous work in this area. And so in our field experiment, we give consumers an access to an online portal or a personal account where they can track their electricity use by appliance and by the minute. There's also evidence that shows in-home displays have an impact, and so do conservation appeals. So the other salient and passive information we provide is sending text message to the household stating that the next day will be a critical peak pricing day, and I'm going to go into more details in a few minutes. There's also active recommendations. There's a study in New York that was done by a hospital where they sent to the treatment and the control group, and the treatment group got a text message saying, "Hey, the flu season is coming. Please take your flu shot," and that seemed to have increased the significant higher number of people in the treatment took the flu vaccine versus the control group. And lastly, the providing pricing information. So none of the other groups, got pricing information. That is, we include critical price information in terms of, what the actual price will be to the consumers in that group, right? So what's the contribution of this paper? This is one of the first papers to look at the appliance level analysis and computing price elasticity of demand at the appliance level. It's a large scale study in the sense that it's conducted over a 2-year period and have minute level and household level observations, and we analyze both increasing prices during peak demand during summer and decreasing prices during off-peak demand during winter. And then examine the relative effectiveness of passive and active information appeals in the same study. So the motivation for design, as I said, there is evidence that salient and active recommendations may matter. So we the first is the access to online portal for the passive information. And text message that says that the critical peak pricing period, and then text message with recommended actions in terms of, hey, tomorrow is critical peak pricing, reduce your electricity usage, or providing the critical information, pricing information. So we connected with the organization called Pecan Street. It's a non-profit organization in Austin, Texas, that works on socially active, socially relevant measures, and reducing electricity is one of the measures they work on. They recruited 280 single-family households through email outreach, and then households were randomly assigned into one of 4 treatment groups or the control groups. And the treatment groups were told that there would be up to.
Praveen, sorry to interrupt you. Yeah. I think your slide is stuck on the. Your presentation is stuck on first slide. So can you try to navigate to the slide which you're talking on right now?
Oh, hold on.
I'm sorry about that.
Yeah, it's what do you see now?
We are all, I think, able to see just your introduction slide, the first slide.
The first slide?
Yeah.
Oh, I didn't do any. Let me.
Can you tell me which slide you want?
Let me stop presenting. Okay, you're able to hear me well, though, right?
Yeah, sound is good.
Why don't you go to slide 8?
Okay.
And I'll just say next, maybe.
Yeah, let me share the slide.
Yeah, I'm glad I sent it to you.
Just give me a moment, okay? It's still in the process.
I wonder why that happened, because it was progressing on my screen.
Yeah, sorry about that. There seem to be some technical problems going on entire day. Just
no worries. That's why I sent it to you guys.
Yeah. Can you try sharing again, and I will try to take control, and you can say next whenever you want to go to the next slide. Just try sharing at your end again, because it seems I'm having problem with sharing as well.
Okay. Are you seeing it now?
I'm able to see the first slide, so let me see if I can actually
navigate through. Second slide?
Yeah, I think I can navigate with whatever you are sharing. So just tell me which.
Well, I'm able to move forward. Are you able to see research questions now?
Yes.
Yes.
Oh, great. Okay, so I'll just do what I have here, and then I don't want to. So where I stopped at is. So the contributional study, it's an appliance level analysis. It's large scale, analyze both price increases and decreases, and examine the relative effectiveness of passive and active information appeals. As I said, this Pecan Street recruited 280 single-family households. They were randomly assigned to the 4 treatment groups and the control group. We also have data from a second. And then there's a second pricing field experiment about during off-peak periods, which is the winter months. So this is the map of Austin. We run this experiment in the Mueller neighborhood, which is a typical single-family housing residential neighborhood in Austin, Texas. These are the demographics in Mueller neighborhood versus the rest of Austin in terms of income, unemployment, percent high school graduate, bachelor's degree, percent residents over 65, residents under 18, median value of ownership, these ones indicate the margin of error overlap, which means the Mueller neighborhood is pretty similar to the Austin in 5 of the 8 characteristics. It's a pretty representative neighborhood. And these are the appliance level meters that were installed by the Pecan Street in these households. And again, I said it's over a 2-year period. There were 27 treatment days, which were critical peak pricing days. And the typical summer rate is 16 cents per kilowatt hour. And all the treated participants were told that they could save up to $700 over a 2-year period, and average summer monthly use about 1,100 kilowatt hours. So it's pretty significant saving for them. And the control group receives nothing. And there was also a second data from a second control group from a different part of Austin. The first treatment group, 44 homes, they have access to an online portal. They can track their appliance level electricity use by the minute. And the passive and active text message appeals. The passive one is second treatment group, 46 homes. They get a text message 24 hours before the critical peak event that a Pecan Street project critical peak event is taking place tomorrow, 4 p.m. to 7 p.m. That's the hottest days in Austin, Texas. And this is a active text message, which is a Pecan Street project critical peak event taking place tomorrow, 4 p.m. to 7 p.m. And with the active message of pre-cool your home or reduce air conditioning usage or do not use your clothes dryer. And the fourth treatment group is a pricing, which says, a Pecan Street project critical peak pricing event is taking place tomorrow. Your experimental electric rate will be 64 cents per kilowatt hour from 4 p.m. to 7 p.m. So that's, they know the experimental rate. And the goal is to replicate the high critical peak price. This is where Pecan Street went to the Austin Electric saying that, hey, if you were to install a critical peak price, what would that be? They said it'll be about 64 cents per kilowatt hour, and that's what they used. Now, challenge is that, Pecan Street is not a utility. It is a common challenge in this type of work. We followed the prior research in this area. So all the residents get a experimental bill, which they don't actually pay. They only pay the actual bill from the Austin Electric. And if the experimental bill is lower than their Austin Energy bill, then the difference is deposited in their account. And then at the end, they get paid out, and if there's a negative balance, it gets zeroed out, right? So the control group, they receive nothing from Pecan Street. There are no further interaction. And we also have, as I said, another minute level electricity consumption, a different sample from a different part of Austin, right? So data is at the minute level, appliance level over a 2-year period. And for rooms with no large appliances, the data at the room level, we have about 360 million observations to play with. And in terms of the demographics, this is the income, education, preferred thermostat, temperature, number of televisions, have solar systems, number of residents, square footage of the house. And these are the means and standard deviation in the control group and the treatment group. And you'll see that, there is really no significant difference between the control and the treatment households among any of these demographics. Right. And this is the non-event day. That means there is no critical peak day there on a non-critical peak days. And this is the electricity consumption in kilowatt hour per minute within these 5 groups, and none of these are significantly different from one another. Let me pause here. Any quick questions, comments? All right. So moving on, the nice thing in this study is that the critical peak periods, they start sometime in June, which is when the hot months, but we have data 3 months before that, right? So we can track the behavior of the electricity usage of the treatment and the control group in the pre-treatment period. So here the dependent variable is the electricity usage, and the dependent variable is the group they are in after controlling for the household fixed effects and time fixed effects and so on. You can tell that there's really no significant difference between the pre-treatment electricity usage between the pricing group and the control group, the text with action the control group, and the portal and the control. Only with the simple text seem to have a slightly higher usage. And again, you should also appreciate that not getting significant effects with 300 million observation, or 4 million observations, it's pretty good. So it shows that randomization really worked. And also we tested the random assignment with the outside control, the group of households from a 27 households in a different part of Austin. Right. Again, there is no difference in the electricity usage between the control and the house and the household groups, and they're relative to the treatment groups. The left out group is the treatment group, and there is no significant difference between the treatment and the control in the Mueller neighborhood and the outside households. So again, these treated households are pretty similar to the representative households in not just in the Mueller neighborhood, in a different part of Austin as well. Right. Again, I just want to make sure that the randomization worked well. Right. Again, these are I'm going to show a bunch of graphs in terms of the electricity usage of control and the treated group and each of the treated groups on non-event days. So these two solid bars, the vertical bars, are 4 p.m. to 7 p.m. That's when the hottest time during the day. And this is the electricity usage, on non-event days on a 24-hour period, pretty similar between the portal and the control. Similarly, for the text message, pretty similar electricity usage between the text message and the control group. Again, the graphs are pretty similar, even with the text plus action and the control group on non-event days. And this is for the group that got the pricing information on critical peak days versus the control on non-event days. So just to show that each of these groups were pretty similar to the control groups, and in terms of their electricity usage. Okay. So we use a triple diff and diff approach to estimate the average treatment effect, and random assignment assures there's no other confounds, but we also did a lot of robustness checks, right, to make sure that the random assignment worked, and also check the random assignment with a sample from elsewhere in Austin as well. And we get similar results with the standard treatment minus control difference approach as well. So let me spend some time here on the econometric specification here. Our focus is on this triple diff and diff, where D is the dummy for critical peak day, T is for the treated household, and P is a dummy for peak time. That is 4 p.m. to 7 p.m., which is the hottest time. So what this coefficient tells us is how did the treatment group, what was the electricity usage of the treatment group relative to the control group on the critical peak day in the critical peak time, which is 4 p.m. to 7 p.m. after controlling for all possible main effects and the two possible two-way interactions and household fixed effects and time fixed effects, right? So I'm going to focus on this triple diff and diff coefficient that tells me the electricity usage of the treatment versus control on the critical peak day and the critical peak time. Okay, so I'm going to focus on that particular coefficient. And these are the results. Again, the standard errors are all clustered on the household level, right? So if you look at portal electricity usage, did not make any difference at all. Providing a online portal access to the to the treated group, and where they have access, where they can have access to their electricity usage during by the minute advanced plans, didn't make any difference at all relative to the control. Sending them a text message that hey, tomorrow is critical peak event, did not make any difference at all. Giving them a concrete action, hey, tomorrow is critical peak event, do not use your air conditioning or your clothes dryer, doesn't make any difference at all. But suddenly, but when you give them the pricing information, hey, tomorrow is critical peak event and your experimental rate is 64 cents per kilowatt hour, significant reduction in the electricity usage. The effect size is about 14% reduction in their electricity usage during that period, right? So so essentially, giving price information matters a lot. And this also, is in line with the more emerging literature in marketing where consumers were put in fMRI machines and showing them price information. And when consumers see price information, a specific part of the brain gets activated, right? That is more related to decision making. So it's sort of like suddenly when people see price information, they are taking an action. Right. So now I'm going to show you a bunch of figures to show that this is the on event day, and these vertical bars are 4 p.m. to 7 p.m. So on this event day, there is absolutely, the lines are on top of each other in terms of the electricity usage for the portal group. And this is for the text message as well. Again, you can see just like, on the econometric results, the usage is very similar between the control and the text message group. And text message with action versus the control, again, very, very similar in terms of the electricity usage. But look at the big difference in the pricing group. The red is the treated group, the green is the control group, and as you can tell that there's a significant drop in electricity usage when they see the pricing information. And also, if you look at this graph a little bit outside, there seems some, it continues on past 7 p.m. as well, right? And then before 4 p.m., it's not like they were using the electricity a lot before 4 p.m., right? So it's not like they were pre-cooling their home or something, and this reduction stay on for a bit, and then we'll see if that is statistically significant. And the biggest reduction in the appliance is from the electricity use, air conditioning usage. So you can tell from this that there is significant reduction in air conditioning usage during the critical peak period, 4 p.m. to 7 p.m. Again, as I said, there was no significant usage before 4 p.m. and a slight decrease after 7 p.m. as well. So looks like the AC is the one that they reduced that they reduced the most. So clearly, to summarize, there is a clear effect of pricing information, that giving consumers specific price information of the critical peak period leads them to reduce their electricity usage. I haven't shown you this graph, but the pricing effect is stronger in the hotter months, which is June, July, and August. By September, it sort of drops down, and the air conditioning effect, looks the same as the overall usage effect. And there is really no evidence of an effect from all other treatment groups, which includes giving them an online portal, text message, and text message with an action. Right. So in terms of where this reduction is coming from, 62.5% reduction is from air conditioning, 10% is from the living room usage, remainder is from all other usage. So having data by appliance and by living room, gets us to say where the reduction is mainly from. So if you convert it to elasticities, it turns to an overall elasticity of minus 0.04 and air conditioning of minus 0.06, and very inelastic, and typical studies in electricity have shown before that when there is a price increase, it's a pretty inelastic market. Although our magnitude, absolute magnitude is a bit lower. Typically it's around 0.1 or minus 0.1 I meant. This is to see if there's a spillover effect, either before the treatment period or after the treatment period, right? Clearly before, in terms of total usage is this block and AC usage. So even though they reduce the electricity usage during the peak period, there is no evidence of using it more before, either in terms of total usage or the air conditioning usage. It's not like they were pre-cooling their home before the critical peak event. And actually, even better, they're actually continuing to reduce their usage significantly less than the control group, even after the peak period of 7 p.m. So there's still a significant reduction, both in the air conditioning usage and the total electricity usage after the peak period. So it's a nice, positive spillover in terms of electricity conservation. Now, we did, many robustness checks. One of them is, hey, are consumers responding to pricing, or is it just for hot days, right? So what we've done is, examine behavior of the pricing, the treatment group on other hot days. That is, check whether people are responding to the pricing information or just broadly to hot days. So perform a test where we picked, non-event days where the temperature was higher than 90 degrees Fahrenheit in the summer for the pricing treatment, and we find that there was the results were statistically insignificant. In that, on non-event days, the electricity usage of this pricing group was no different from the control group, right? So there's no on other hot days, there's no significant difference, right? That means when we give the pricing information on a critical event day, that's making a difference. And now we looked at, in the text message with action, we asked that, one of the messages was, hey, pre-cool your home, right? So in terms of the on those pre-cool messages for the text plus action, they did follow those directions, that when we send a message pre-cool your home, in fact, they significantly used more AC before 4 p.m. But unfortunately, they didn't follow through in terms of reducing their electricity usage during the peak event. But the messaging did work in terms of they did pre-cool their home, but implicitly, during the 4 p.m. 7 p.m. they did not then reduce the AC usage, right? So again, as I said, we have the other control group, which is in a different part of Austin, right? So we compared the electricity usage of the pricing treatment group, the Mueller group, with the other control group from a different part of Austin. Same model as before, and we get a very similar triple difference coefficient of minus 0.42, very similar to what I had before of minus 0.39. Right. And that's the critical peak event where where the we were looking at people's reducing their electricity usage. Now the question is the critical peak pricing event effect symmetric in terms of what happens when the on the winter time when there is a lot of power in the grid? In Austin there are a lot of windy days and there's a lot more power in the grid. And so the experiment was to lower prices at night time when wholesale prices are cheap. The typical off-peak price is 5 cents per kilowatt hour, and that price was reduced to about 2.5 cents per kilowatt hour, and examine their behavior. Right. So West Texas has a lot of wind power and low wholesale prices, and these households in the 62 households in the pricing trial were told that the treatment in the 5 windiest months, March, April, May, November, and December. And the treatment occurred is 10 p.m. to 6 a.m. again over a 2-year period. Price was reduced to 2.65 cents per kilowatt hour. Again, they received text messages 24 hours before the first day of the month saying, hey, this month is off-peak pricing period where the experimental price is 2.65 cents per kilowatt hour. It's on 10 p.m. to 6 a.m. And this is graphical. I'll show the statistical results in a minute. This is 6 a.m. This is 10 p.m. We're looking at behavior after 10 p.m. and before 6 a.m. And again, green is control. This reddish one is the treatment, and you can tell that they're using more electricity before 6 a.m. and they are reducing their electricity between after 6 a.m. and before 10 p.m. Right. So clearly they're shifting in some sense. There is some load shifting that is happening here. There is the thing that they would have normally done during the day. Now they are doing it early in the morning. Right. And in terms of again the triple diff and diff results, right? They're from 10 p.m. to 2 a.m. there's no difference between the treatment group and the control group, but from 2 a.m. to 6 a.m. their electricity usage is significantly higher than the control. Among that, the ones that where its highest is in the electric vehicle usage. So they are now charging their electric vehicles more early in the morning when the off-peak price is lower. And converting this to elasticity leads to elasticity of minus 0.28. Looks like people are a lot more sensitive to price decreases than to price increases, sort of like in the reference price literature, that people are and when there is a price decrease, they are using their electricity more than when there is a price increase. The other way to look at it is that they would much rather charge their electric vehicles earlier in the morning when the price is lowered, as opposed to the inconvenience of shutting down the AC during a hot summer day. This is a lot more elastic in this sense. And then we compute the welfare implications and simple back of the envelope calculations for welfare gains for 27 peak days. is about $32.38 per household. Extrapolating to Austin, Texas, is about $11.7 million. To all of Texas is about $239 million. And then, based on the data from the Department of Energy in Texas, we were able to compute, what is the reduction in carbon dioxide emissions on these 27 peak days. That turns out about 137,141 tons, metric tons, sorry, 137,141 metric tons, which is about a 14% reduction in carbon dioxide emission during this time. So there is a lot of positives for reducing the electricity usage on critical peak periods. Similarly, during the off-peak pricing welfare, same approach. Welfare gain for household is about $2.36. Extrapolating to Austin would imply $851,000 over a 5-month period. And by the way, these welfare computations do not include any other environmental benefits and costs in critical peak pricing by building inefficient plants, for example. So conclusion, the critical peak pricing messaging reduces electricity usage, elasticity of demand about -0.04 to -0.06. And we haven't seen much evidence of shifting of electricity use to other periods. Response is driven by reducing air conditioning, suggesting targeting approaches. The pricing treatment is the one that worked the best, not the salience of a passive or an active text message worked. When the price was lowered, there is clear load shifting from lower off-peak night pricing, and it's also more elastic. And there are possible welfare gains and that we show. Questions, comments, thoughts? If not, I'll hand it over to Brian.
Yes.
Let me stop presenting.
I have to change my preferences. I'll be. Can people see my screen?
Yes.
You can see my screen.
Yes.
Okay, I'm sorry about that. It wouldn't. My preferences weren't set up to allow me to share it. And everyone can hear me okay?
Yeah.
Great, thank you. Sorry about that. I first want to thank Praveen and the conference organizers for their flexibility. I have EMBA teaching, and they had to move the schedule around a little bit, and I had my second COVID vaccine today. And thank you, Praveen, and to the organizers for being so accommodating. I also wanted to, as a quick disclaimer, say that Jesse and Ken are actually both co-authors of mine, so take what I say with a grain of salt. I was fortunate to be able to read a very early draft of this paper and provide some quick thoughts to Ken, and I was thrilled to get the chance to read it again in its more final version. Praveen was incredibly clear with the discussion, so I'm not really going to do much summarizing of the paper and more focus on discussing what my main takeaways were. Their main findings were that there were, one, a minimal response to information treatments. Critical peak pricing reductions were about 14%. 74% of this was due to air conditioning reductions, and that the nighttime program with lower prices led to load shifting to charge electric vehicles. And I do want to say that their data are terrific. Being able to get appliance level information in an experimental setting to be able to see how consumers actually change not just electricity consumption, but the consumption of what actually matters to them, charging an AV or cooling their house, I think is terrific. The interpretation within the papers of some of these effects were that, demand elasticity is larger, for the rate decreases, negative 0.28, and it was very, very small for increases. They also pointed out that the 2013 and 2014 comparisons, when they looked across the 2 years, showed some dissipation of the results. And Praveen didn't focus as much in the talk about that, but it was one of the highlighted results in the paper. And then again, of course, the load shifting at night. And if I was to critique the paper, I think it would probably be I could use a little more tying together of some of these main results. Right now, there's sort of a list of really cool findings, and I didn't see how some of them were necessarily tied together. So I'm going to provide a few of my interpretations, and then Praveen, if you like them, just great. If you don't like them, just ignore them. For me, my interpretations are really that households are much more likely to respond with long-term adjustments. They are not sitting at home. You find out that you're going to have a high price day tomorrow. So you're going to drive home, or maybe you're still at home. You're at your thermostat, and 4 o'clock hits. You turn the knob, and now you don't have to pay the high price. Right? People are much more likely to maybe adjust their thermostat, knowing that they could be exposed to a critical price shock, to maybe allow their house to heat up. So long-term adjustments, I think, are what we're going to expect. Because of that, automation would be important for price response. And my final point is, I thought that the dissipation evidence wasn't yet conclusive, although I think that there's something that they could do to make that point even more so than they do right now. So focusing on these long-term adjustments, if we go back to the figure that was shown during the talk, you can see, right, that in the pricing treatment, houses, they adjust their thermostat down, they consume less electricity during these peak periods, and then that reduction continues afterwards. So again, they're not immediately turning it back up. So something led them to do a more long-term adjustment. It's not only affecting the treatment period. These were the triple difference results, focusing on that treatment period, about negative 0.4 on electricity use, and you see the same magnitude result for adjustable AC. So really, again, emphasize the importance of air conditioning here. Their difference in difference estimates, I actually like this table even more, because here you got to see not just the critical period from 4 to 7 p.m., but that spillover afterwards, where people don't yet immediately adjust their thermostat back. So I think the fact that you see that post-critical peak spillover really emphasizes long-term adjustments. And that gets me to the second point about the importance of automation. So one thing I really want to highlight as an aside is that the identifying variation in this paper, and really all these papers that are identifying a price elasticity by assigning people into different treatment bins, in which one household is a control price and the other one gets exposed to price shocks. This is not experimental variation in hourly prices, right? We're not actually measuring just a short-term response. Essentially, we compare the difference in consumption across households in that price treatment bin and the control when those prices are different. So in the control bin, you're facing your average, 12 cents per kilowatt hour price or whatever it is. And then in the treatment bin, on some days you get a really, really high price you don't want to be exposed to. So if I know I'm going to be exposed to these these occasional shocks in critical prices, I might just allow my thermostat to let my house get up to 74 degrees in the summer instead of 72. And this long-term response is actually going to look like a short-term price response, when in fact it was a response to the treatment assignment. And one thing to notice, that these critical price events aren't actually random. They happen on the very hot days in the summer. And those are the days when such a thermostat adjustment will actually have a bigger effect on consumption, because on the very hot days, it's harder to cool off your house. So essentially what you get is something that looks a lot like a short-term price response, when really it was the fact that you did a long-term response maybe to your thermostat, and then on the really, really hot days, you see a even larger reduction than you do on an average day. Now, I don't think that's the only thing happening here, because you see people sort of readjust their thermostat, presumably, an hour or two after the critical period. But these elasticities are capturing both the short-term response as well as long-term response as well, which is, again, why automation could be very important. This was the EV result, which, again, I love the data. I think the amount of load shifting you see here is tremendous, especially with right when the price drops for your electric vehicle. And one of the nice things about charging your electric vehicle is that it's really, really easy to automate when that charging occurs. It's a one-time adjustment. You say, nope, start my charging at 11 p.m. or whenever the rate would drop. It charges your vehicle then. So it's a very low cost activity, much lower than, again, me having to adjust my thermostat every time there's a critical day. So because of that, and before I get to the takeaway, I want to sort of compare the daytime response that Praveen had to what we had found in our 2020 paper. This was with Wes Hartman, my advisor, and where Praveen sort of sees this reduction in consumption that occurs during the critical peak period and continues after. When we looked at treatment conditions that had a programmable thermostat that you could program based on the price, that's the yellow and the green lines in the graph on the right. What you saw was that you saw the exact same drop right when the critical peak period began. But then for us, you actually saw the treatment groups go higher in consumption after the critical period ended. And this was because the house had gotten warmer. And then once the critical price went down, the thermostat then allowed the AC to start up again at full power. Those households who were assigned the smart thermostats actually were consuming more once that critical window had ended. And the utility actually liked this. In terms of overall consumption, you weren't reducing consumption by as much, but they actually wanted to sell electricity once you were outside of the critical window. What they were focused on for their gains was reducing it just during that critical peak period. So I think it sort of highlights what happens when you have automation on the right versus what happens when you're relying a little less on automation and you're requiring humans to adjust their thermostats themselves. So for me, the fact that you found a low price response in the daytime was not about it being a price increase that might have played into it. It really was the fact that there was not the same ability to automate the response as there was with the electric vehicle charging at night. These were the short-term elasticities that we had in the 2020 paper. And again, it is there so you can see the importance of that automation. So like Praveen and Ken and Jesse, we also had some information treatments, the portal in the red lines, the purple is the in-home display, the blue PCT is the programmable thermostat, and then we had a treatment condition that gave all three. We also found a small effect of information. It was there, but it was a small effect. And one of the things that we thought was really notable is that when you were provided with information, there was a treatment effect, but it didn't matter what the price was. So this was a demand curve we were able to trace out, conditioning on a control group's usage to try to condition out on the temperature and other unobservables. And what you saw in the information treatments was a reduction, but still a completely inelastic demand curve. You can see that they're completely vertical. Whereas in the blue and green curves, there you can see, depending on how hot of a day it is, whether it's a 10th percentile day, sort of a 50th percentile day, or a really hot 90th percentile day, you can see the price response happening at different levels. So for a 50th percentile median kind of day, most of the response was at the lower price level between 5 cents per kilowatt hour and 11. Whereas for the hotter days, it's too hot. I'm not shutting down my AC then, right? I'm willing to pay, even 22 cents because it's just too hot out. But if it goes up to 46 cents, now, again, the smart thermostat sort of kicks in and it starts to cool the house because that's too high of a price based on the settings I set back at the beginning of the summer. So again, trying to highlight the importance of automation. In terms of the last point I was going to make, this is going to be a fairly quick one. The paper talks about dissipation over 2 summers. Again, in addition to the great appliance level data, Praveen and co-authors have a really nice setting in which they get to observe the treatment effect in 2 consecutive summers. This was the table in the paper showing sort of the decline over time. You can see bigger treatment effects in June and September when nighttime temperatures aren't quite as brutal in Texas. So you see bigger treatment effects in June and September, less in July and August. And then if you look from 2013 to 2014, the treatment effects decrease. And this was a point that was made in the paper. One thing that I wanted to notice that it looked like the only statistically significant decrease was in June. And if you look at the AC use, it's a big drop. And if you look at the sort of residual, the non-AC use, that's where I think you really see the drop across the other months as well. So I was suspecting that maybe a lot of this dissipation that they observed was through the non-AC use. And it's a regression I'd love to see. In terms of the reduction that you see in AC use, which again is really only significant in June, I went back and looked at what happened with summer high temperatures in Austin for these 2 years. And June in 2014 happened to be much cooler than June in 2013. And I thought that this could actually explain quite a bit of the reduction for the AC. In terms of the non-AC consumption, this wouldn't explain it at all. And it looks like the non-AC consumption, you essentially have a 0 effect in year 2. So that's something that I'd love to see if they ran that same regression, just looking at the non-AC consumption to help make that point about dissipation. In sum, I really enjoyed reading this paper. It's very carefully done. There's lots of really compelling findings using very interesting data. The big challenge I think that Praveen has is just figuring out which results to highlight because there are so many results here. And then for me, again, what is the overarching takeaway? For me, the takeaway was the benefit of sort of low-cost, long-term adjustments, like changing the settings of when you're charging your electric vehicle, and how valuable automation could be because of that. Again, pleasure to read. Thank you, Praveen, and thank you to the organizers for inviting me.
Thank you so much, Brian. That was a great discussion, and thanks, Nanda and the organizers.
Cool way to end the discussion. We've had a lot of power problems here in Texas, so this is all very topical for us.
It is.
Yeah. Thank you, Brian. Thank you.
Thank you.
Thank you, Ram.